Okay, so today what we're going to do is we're going to explore how to solve equations that contain fractions. Before we do that, let's just go and remind ourselves how to simplify algebraic expressions where there are denominators and where we need to bring in an LCD, because that's what we're going to use now when solving equations with fractions. So if I give you an algebraic expression as follows: 2x minus 8y divided by 3 minus 3, 2x plus y over 2. Remember, in this case, we are working with an algebraic expression. So I'm not working with an equation. I'm not solving for x and y. I'm just asking you to simplify this expression. How do we do this? So remember, when we were doing this section, we discussed how my denominators are not the same. I've got a 3 and a 2. In order to simplify this expression, what are we going to do? We're going to find an LCD. So what do 3 and 2 both go into? They both go into 6. Now remember, if I have a binomial in the numerator of my fraction, what am I going to do? I'm going to put brackets around the binomial, because soon I'm going to multiply by both of those terms in that numerator. So I say to myself, okay, if my LCD is 6, I say 3 goes into 6. How many times? 2 times. So 2 needs to be multiplied by the numerator, 2x minus 8y. 2 goes into 6 3 times. So 3 needs to be multiplied by the coefficient of that bracket. So 3 multiplied by 3 is 9. And that 9 is then going to be distributed into that bracket. So let's carry on. Simplify using distribution. And remember, we are simplifying and we don't drop the LCD. We add like terms. So I have minus 14x minus 25y over 6, and that is its most simplified answer. Okay, now that we've just reminded ourselves how to simplify an algebraic expression, let's look at how to solve an equation using an LCD. Okay, so let's say I'm given the following equation. The equation will say, solve for x. We want to determine the value of x in the equation 2x divided by 3 equals 6. Now, there are two ways in which we can answer a question like this. The first way is I can say to myself, well, 2x is divided by 3. How do I undo something that is divided by 3? What is the inverse operation of dividing by 3? The inverse operation of dividing by 3 is multiplying by 3. So in order to undo the dividing of 3, we have to multiply by 3 on both sides of the equation. So I'm going to multiply by 3 on both of these sides. 3 divided by 3 cancels each other out. It becomes 1. So I'm left with 2x. And 6 times 3 is 18. I'm still not finished. In order to get rid of this coefficient of x, I need to undo the multiplication of 2. So how do I undo something that's been multiplied by 2? We're going to divide by 2. And remember, it's an equation, so what I do on the right-hand side, I have to do on the left-hand side. The 2's divide each other, and I'm left with a 1x. And 18 divided by 2 is 9. Now, I mentioned that there is another way in which we could do this equation. Remember, this 6 is a whole number. And anytime we have a whole number, The whole number is over a denominator of 1. So if I look at this equation now, I have a 3 in this denominator and a 1 in this denominator. So what is the LCD, the lowest common denominator of 3 and 1? The lowest common denominator would be 3. So we're saying to ourselves, in order for me to equate the numerators of these fractions, I need to ensure that the denominators are the same. So here I've got a 3 already. So I say, okay, to get from 3 to 3, I multiply by 1. So 1 times 2x is 2x. On this side, to get from 1 to 3, what do? I have to multiply by 3. So what I do to the denominator, I have to do to the numerator. So 6 times 3 is 18. Now, because my denominators over here are exactly the same, we can basically, as we call it, it's not really correct mathematical terms, but we can drop the denominator, because if my denominators are exactly the same, then my numerators can equate to each other. To get rid of the 2 in front of that x, it's 2 multiplied by x. To undo multiplication, we're going to use division. So we say 18 divided by 2 is 9. Okay, now those were simple examples. What's going to happen if I give you the following example, where I have 2 denominators that are completely different? So for example, I say solve for x, where I have 2x is over 3 and 6 is divided by 5. Okay, so 2x over 3 equals 6 over 5. Now, in this case, we definitely have to use an LCD. Okay, to solve this equation, we need to find an LCD so that I can find the same denominator for both of these fractions. So I say, okay, well, what do 3 and 5 both go into? Oh, they go into 15. So the LCD of 3 and 5 would be 15. So we're saying to ourselves, how do I get from 3 to 15? I multiply by 5. So what I do to the denominator, I have to do to the numerator. 5 times 2 is 10. So I have 10x. To get from 5 to 15, I multiply by 3. So what I do to the denominator, I have to do to the numerator. So 6 times 3 is 18. Now, because my denominators are exactly the same, we don't need to write them anymore. You can write them, but we prefer you not to. So I have 10x is equal to 18. 10 is multiplied by x. To undo multiplication, we use division. My 10s divide by each other, so I'm left with the 1x. And I now have 18 divided by 10. Now, can this fraction be simplified? It can. What goes into both 18 and 10? 2 goes into 18 and 10. So if you are able to, please simplify the fraction. If you are not able to, then write your answer as an improper fraction. We prefer to see an improper fraction as opposed to a mixed number. So I simplify the fraction and I get 9 over 5.